Hello everyone, I am Sir Math. Today, we're diving into one of the most important differentiation techniques in calculus, the chain rule. If you ever struggled with differentiating composite functions, this video will make it super easy for you. So grab your notebook and let's get started. Before we jump into solving problems, let's understand what the chain rule actually is. What is chain rule? In simple terms, it's used to differentiate composite functions or functions within functions. So, we have here the formula. We have dy with respect to dx equals dy with respect to du times du with respect to dx. Okay, so this formula simply means that we differentiate first the outer function. So this part here is the outer function. Then we keep the inner function the same, just as is. Then afterwards, we multiply the derivative of the inner function. Let's break it down with some examples. Okay, let's have example number 1. So we have here y equals the quantity of 4x plus 2 cubed. So for the solution, so we have here the derivative operator with respect to x, 4x plus 2 quantity cubed. So in this scenario, our outer function is just the quantity cube. So meaning we let 4x plus 2 stay the same. So that will be our outer function. And then 4x plus 2 is your inner function. So whatever is inside the parentheses, that is the inner function. Okay, in this scenario, we're going to apply power rule first because we have an exponent here. So for the power rule, the derivative of x to the n is just n times x to the power of n minus 1. So in this scenario, we will bring down 3 first, just like here. So if the exponent is n, we will write first n, the exponent, in the coefficient. So we have here 3. Next, we will write the inner function as is, just this still the same. And then we will subtract 1 from the exponent. Okay. And then lastly, we're going to multiply this one with the derivative of the inner function. So for the derivative of the inner function, we have 4. Then derivative of x is just 1 times x to the power of 1 minus 1 if we apply power rule. So we bring down 1. So take note, there is an invisible 1 here in the exponent. So we bring down 1 and then we subtract 1 from the exponent. And then we add the derivative of the constant. So take note, the derivative of the constant is just 0. So we have here as our first line. Okay. And then we simplify further. So this will give us 3 times the quantity of 4x plus 2 squared times 4x to the power of 0. So take note, x to the power of 0 is just 1. So we will have 3 times the quantity of 4x plus 2 squared times 4. Then we simplify further by combining like terms. In this scenario, like terms are the constants. So 3 times 4, we have 12 times the quantity of 4x plus 2 squared. This is our final answer. See how easy that was? Let's try another example. Example number 2. Here we have y equals cube root of 2x plus 7 quantity squared. Solution. So take note that we can rewrite a radical. So for example here, if we have the nth root of x to the power of m, that is equal to x to the power of m over n. So in this case, if we have the cube root of 2x plus 7 quantity square, we can rewrite this one into 2x plus 7 quantity to the power of 2 over 3. We can now apply chain rule. So first, we bring down 2 over 3. Then we copy the given to x plus 7. And then we subtract 1 to the exponent. So we have 2 over 3 minus 1. And then lastly, we get the derivative of the inner function. So the derivative of the inner function is 2 times, so we have here x, we bring down 1, and then we subtract 1 to the exponent of x, and then plus, then we have the derivative of 7, which is 0. So simplifying this will give us 2 over 3 times the quantity of 2x plus 7 raised to the power of negative 1/3, because 2 over 3 minus 1 is just negative 1/3. And then again, x to the power of 1 minus 1 is just x to the power of 0, which is just 1. So we have 2 times 1, which is 2. And then we just disregard 0. Then take note, since we have a negative exponent, so we get the reciprocal of 2x plus 7 to the power of negative 1/3, which is just 2x plus 7 to the power of positive 1/3. We also multiply 2 here to the 2 at the first part. So we have 2 over 3 here. So 2 times 2, we have 4. Hence, we have 4 over 3 times the quantity of 2x plus 7 raised to the power of 1/3. And since we have a fractional exponent here, we can again apply this rule. So instead of having 1/3 in the exponent, we will rewrite this one as 4 over 3 cube root of 2x plus 7. And this is the final answer. Now that you've got the basics, let's go through a few more examples by combining chain rule with product rule and quotient rule. Let's have example number 3. So for example number 3, we have the given quantity of 3x plus 2 times the quantity of 2x minus 1 cube. Okay, so let's have the solution. So take note, in this scenario, we are going to apply product rule. So according to product rule, if we have the derivative of u times v, where our u is the first factor and v is the second factor, so the pattern should be u dv plus v du. So in this scenario, our u is 3x plus 2, our v is 2x minus 1 cube. So we will write first 3x plus 2, since that is our u, and then get the derivative of v. So take note here, our v is 2x minus 1 quantity cube. So we're going to apply chain rule here. So we will put down 3 first, copy the given, 2x minus 1, then subtract 1 to the exponent, and then again, don't forget to get the derivative of the inner function. So derivative of 2x is just 2 times 1, and then minus, then derivative of 1 constant, it's just 0. And then we're in the next part, so plus v du, so v is 2x minus 1 quantity cube, and then derivative of u, so derivative of 3x is just 3 times 1 plus derivative of 2 is 0. So we can simplify further. Okay, so here our exponent is now 2 into x minus 1, and then 2 times 1 minus 0 is 2, and here in 3 times 1 plus 0 we have simply 3. Then take note, we have to combine like terms. So we have two constants here. We have 3 times 2, which is just 6. So we put 6 at the first or the leftmost part, and then we just copy the given, and then again leftmost part also of the second term, we're going to put the constant 3. So take note, we can still distribute 6 to 3x and plus 3x and 2. So we will have 18x plus 12 quantity times the quantity of 2x minus 1 squared plus 3 times the quantity of 2x minus 1 cubed. So we don't need to expand. So it's just, this is now the final answer. Let's go to the next example. So for the next example, we have y equals the quantity of 4x plus 3 squared all over 2x minus 5. Solution. In this scenario, we need to take note that we have a rational function. So for rational functions, we will use quotient rule. So the quotient rule dictates that if you are going to get the derivative of u over v, where our u is the numerator and v is the denominator, the pattern is v du minus u dv all over v squared. So in this scenario, our u is 4x plus 3 quantity squared, and then our v is 2x minus 5. So according to the formula, we write first v. So v is 2x minus 5, and then get the derivative of u. So we bring down 2 first. So for du, we will apply chain rule. Bring down the exponent 2, copy the given, subtract 1 to the exponent, and then again, don't forget to get the derivative of the inner function. So we have 4 times 1 for 4x, and then 0 for 3. Then we have minus, our u is 4x plus 3 quantity squared. Then we have the derivative of v. So the derivative of 2x is 2 times 1. So minus the derivative of 5 is 0. All over, so again our v is just 2x minus 5. And according to the formula, it's v squared. So 2x minus 5 quantity square. So we simplify further. So here, our 4 times 1 plus 0 is just 4. Our 2 times 1 minus 0 is just 2. And then we can multiply. Let's have the next slide. So multiply 4 and 2. So that's why we have 8 here. Okay, and then of course, the 2 in the second term, we just change its position to the leftmost part. So it's here. Okay, so again, take note, we can distribute 8 to 2x and negative 5. So, before we distribute, we can actually factor out the common factor. So the common factor here is 4x plus 3. So we factor out 4x plus 3. So that's why we have 8 times 2x minus 5 here, minus 2 times the quantity of 4x plus 3. And there is no more squared because we factor out 4x plus 3. So we distribute 8 to 2x and 5. So that will give us 16x minus 40. And then here we distribute negative 2 to 4x. So we will have negative 8. Then we have here minus 6. So if you try to simplify this will give us 8x minus 46 in this part. So the final answer is 4x plus 3 quantity times the quantity of 8x minus 46 all over 2x minus 5 squared. Now we're done with the examples. Let's proceed to the common mistakes you might apply when using chain rule. Here are some things to watch out for. Number 1. Forgetting to multiply by the derivative of the inner function. So, example, you might answer like this. You just apply power rule. So, you bring down 3, copy the given, subtract 1 to the exponent, and then you might think that this is your answer already. So, this is very wrong. You need to remember that there is the derivative of the inner function. So we need to get the derivative of 2x plus 1, which is just 2 times 1 plus 0, which is 2. So 2 times 3 is 6. So we will have 6 times the quantity of 2x plus 1 squared. So that will be the final answer. Next, incorrectly applying the power rule without considering the inner function. So you might be having an error in applying power rule. So not all exponents are the same. So just be careful. And then lastly, not simplifying expressions properly. So example, when we did the quotient rule, so you should simplify it further. But take note, you don't need to expand everything. You just need to simplify as much as possible. You just need to distribute the constants, and then if you cannot apply simplification anymore, then that's the final answer. Awesome work today. We learned how to use the chain rule to differentiate composite functions, and we went through the multiple examples. If this video helped, don't forget to like, subscribe, and hit the notification bell so you don't miss future calculus tutorials. Let me know in the comments if you want more practice problems. See you in the next video. Bye bye!